Instruction skill number 19 is understanding similar figures. And I think this might be my favorite math skill ever. This one I absolutely love. Let's take a look over here, first of all, at what it means to be a similar figure. Here is an example of similar rectangles, where you have a 10 by 5 and a 24 by 12. I thought of these when I was learning them as mama and baby figures, or father and baby figures, because the baby is just a smaller version of the mother or father figure. But the DNA is the same. They belong together. You can't just put any two rectangles together. They have to fit in a certain way. They have to be proportional. The angles have to match, and in this case, they're all 90, and the sides have to be proportional. So let's talk about what that means. How do I know that sides are proportional? How can I tell if this is really a baby to that mama? Okay, so I'm going to use, let me think about this. This is not how I would have set it up, but it works. This is the baby dimensions, 10 and 5, and this is the mama, 24 and 12. This is the height, so baby's height and mama's height, and this is the width. So how can we tell if these truly go together? You do it with peanuts. You draw a peanut this way, and you multiply. And I'm using my calculator because we're learning the skill. We don't want to get bogged down in the math. 24 times 5 is 120. And then you draw a peanut this way. And you guessed it, you'll multiply it. 10 times 12, I can bring that 0 over, and 12 times 1 is 12. If these are the same, and these are called cross products, if these are the same, that tells me that the mama and baby go together, that mama belongs to that baby and vice versa. So let's look at a triangle. With triangles, you have to check your angles, that baby A matches mama A, baby B matches mama B, and baby C matches mama C, and that the sides are proportional. So let's check to see if these proportions hold true. So I'm going to do 4 times 10. That is 40. And then I'm going to do 8 times 5. That is 40. So those check out. But we also have to check these. 5 times 6 is 30. And 10 times 3 is 30. So yes, that baby goes with that mama all the way around. And they're telling us that we can use the calculator to do what we need to do. So that's nice that we have the calculator. So let's take a look at this problem, this story. Chris is having a poster made from a favorite photo. He asked the printer to make the poster 22 inches wide. So here's the photo that Chris has. There's the height and there's the width. And then here's the poster. There's the height, and here's the width. He asked the printer to make the poster 22 inches wide. So he wants it to be 22 inches, and he's increasing that from 4 inches. And then we have the 6, and we want to know what the height of the poster will be. So we have similar figures here. We have a baby figure and a mama figure. So let me put these down here. We'll start with the baby one, and then we'll have the mama one. And we're going to compare their heights and their widths. And I have no idea why that went sideways. All right. Baby's height is 6, and baby's width is 4. Mama's height, we don't know, but we know her width is 22. And so we have what we need here. We are ready to do the math. We'll draw a peanut, and we always multiply peanuts. And they told me that we can use a calculator. So I'm going to, 22 times 6 is 132. That's the peanut, but we're not finished because we still have that 4 sitting there, and that gets divided. 132 divided by 4 is 33. And the poster is measured in inches, so that gives us answer number 5. Similar figures are the same shape, but may be different sizes. Corresponding matching angles must have equal measure, and corresponding sides are proportional. They must form equal ratios. For example, if the picture is enlarged to twice its original width, the new height would also have to be twice the original height. To solve these problems, here's how they approached it. Because the poster is an enlargement of the photo and the poster are similar figures. The ratios of corresponding sides are equal. Write a proportion. Each fraction is a ratio of corresponding sides. Width of the photo is 4. Width of the poster is 22. Height of the photo is 6. Height of the poster is h, or that proportion. And then you cross multiply. You would do 6 times 22 and 4 times h to get 33. The height of the poster is 33 inches. This method absolutely works. Also, my method works of mama and baby. You can use either one you want to use, whichever makes sense to you. So let's practice. To find the distance D across Heron Lake, and that goes with this picture, Lacey marked off distances and drew the picture shown at the right. Which proportion can you use to find this distance? Now this one's tricky. I can see the mama and the baby, but baby's standing on its head. Baby is upside down when compared with mama. So I'm going to sketch this, not sketch it, but I'm going to color it for you so we can really understand what's going on here. So here's what she's trying to find. She's trying to find the distance across this lake. And so she drew some measurements. These are measurements that she could measure with some sort of measuring device. And here's the mama triangle. Okay, so let's really be sure we understand what we're looking at. We don't know mama's height. That's the thing that's in question. But we know mama's width. Okay, so there's the mama triangle. And now let's look at the baby triangle. Again, these are measurements that the person in this story was able to make on land. You could measure these with a measuring tape if you had the right amount. And for baby's measurements, we do know what we're looking at. We know that baby's width is 9 and baby's height is 15. So you just have to be very careful that you realize baby's standing on its head. So to set this one up, if you use my method, you're going to need a space for the mama and the baby. And we're going to make a proportion out of those. So we want 2 equal fractions. And then we're going to put mama's height and mama's width. And then baby's height and baby's width. So be very careful. Mama is how tall? We don't know. Mama has a width of 34 yards. Baby has a height of 15 yards because she's standing on her head, and baby has a width of 9 yards. It is very important that you make sure all of them are yards. If one of them were feet or one of them were inches, you have to get them in matching units. Doesn't have to be yards, but it has to match whatever you use. Okay, so here's the peanut. 34 times 15 is 510. And 510 divided by 9, I bet I didn't have to solve it, did I? Is 56.6 repeating. So the distance across that lake is about 57 yards. What I want you to be aware of is the peanut. What is getting multiplied in the peanut? All right, let's come back over here and try to match our proportion. Mine is probably going to be different because I'm using my method. But it's okay. We can still use that. We know that my method is correct. So let's bring it over here. I don't need Bab in there. And see if we can match what we have here. I have D over 34. So this looks good. But I have 15 over 9, and that doesn't match here. That's the only D over 34 that I have. So here's what I have to do. I have to use the peanut test. And here we go. We have, sorry, let me get a pen. We have 9 and 34 in the peanut. We have 9 and 34 in the peanut. We have 15 and 34 in the peanut. We have 43 and 15 in the peanut. And we have 24 and 15 in the peanut. Which of those peanuts matches mine? There it is. That's your answer. There are different ways to set up the proportion. That is just part of math. When you get into advanced math, there are different ways to set up a problem. But your answer has to match their answer. And if it doesn't matter how you set it up, you're getting the same answer. So number 1 is going to be number 3. Okay, let's look at an application. Farhat wants to reduce a photograph to wallet size. At most, the copy can be 4 inches high. At this height, what will the width of the copy be? And so let's look over here at these 2 photos. And I already see it. Here's the mama. And here's the baby. So set your proportion up just right there. You've already got your proportion. You really don't even have to set it up. You've got 10 over 8 and 4 over a question mark. 10 over 8 equals 4 over the unknown. If you want to go the step further, just to understand it, you're doing height over width. This is the mama, and this is the baby. The peanut is 8 times 4. That's 32. Divided by 10 is going to be 3.2 inches. And did we have to find an answer? Or yes, we did. And there it is, 3.2 inches. And we're done with that one. They didn't give us a procedure this time, just applications. All right, 2 trees stand side by side. The smaller tree is 8 feet high and casts a shadow that is 20 feet. At the same time, the larger tree casts a shadow that is 48 feet long. To the nearest foot, how tall is the larger tree? Well, I really want you to see the shapes that are involved here. So I'm going to draw them in. You're looking at this height and this shadow. So there's a mama triangle. And then you're looking at this height and this shadow. There's the baby triangle. So you do have the mama and the baby. It's a little bit harder to see, but it's there. And those numbers are incredibly hard to read. I don't know what happened there. That's 20, and this is 8. Maybe somebody wrote those in on my master copy. Let me look at that, because that just looks bizarre. Page 51. I need to get to the page I'm using. Okay, I don't know if somebody wrote that in or it's very strange, but anyway, here are the dimensions. And we are looking for the mama's height, the height of that larger tree. So the proportion is here. We have 8 over 20 and h over 48. If you want to set them up, this is baby. This is mama or daddy. And this is height over shadow. But you're ready to solve it once you see those numbers. So you have 48 times 8. We cross multiply those. The cross product is 384. And you divide 384 by the number that's not in the peanut. That's 20. And that is 19.2. These were feet. So Mama is a little over 19 feet tall. To the nearest foot, she is 19 feet tall. Some common ones of these are the height of a flagpole, the height of a tree, the height of a building, where you use something that you can measure to estimate something you cannot measure. Very useful skill if you're trying to calculate heights and distances.